All right, let's talk about observation versus inference. So this is something that's really important to science. It's also really important to chemistry, which is a science where you typically don't see what you're working with. We talk about atoms, we talk about protons, electrons, molecules, things that we can't see with the naked eye on an individual basis. We can, though, see their effects around us when we do different experiments or different reactions, and that's how we can then decide what they look like, how they bond, and how they act. And observation and inference is something you do every day, even if you don't know it. We're just going to give some names to it right now. Okay, so first off, an observation. And you know what that term means. It's things that you observe. So really there's two types of observations, though. There's qualitative, so think quality, and that uses adjectives. And so these would be descriptive words, like red or dry or hot. Okay, so things that we would use to describe, and they're things that we can observe so that we can physically see. We can also measure our observations, and those would be quantitative observations. So quantitative, quantity, these use measurements. And so it would be things like, 3-gram piece of cereal or a 2 millimeter long worm, things like that. So both of these are observations. They're concrete. We can prove them, essentially. Okay, we can look at an apple and say, it is red. We know for a fact because we're looking right at it, and it's red. Or you can touch a piece of paper and say, okay, that's dry. Or you can measure something and see how much it weighs, what its volume is, things like that. Okay, we make inferences all the time. Anytime we make an observation, more than likely in our heads we're making inferences. So inference is different than an observation. An observation is something qualitative or quantitative. It's something that we can look at and we can say without a doubt. Inferences are conclusions that we draw based upon those observations. So the conclusions that we draw are usually an explanation for something we observe. They're based on past experience and prior knowledge, and they can change with new observations. So let's say you go home this afternoon, you walk through the front door, before you see anything, you smell pizza. That smell, that's a qualitative observation that you've just made. Instantly in your brain, you're going to start making inferences. Maybe you're thinking, ooh, Mom bought pizza for supper tonight. Or maybe you're thinking, someone ate pizza while I was at school. Both of those are inferences because you haven't observed anything. You don't know if there's pizza there, if someone else ate the pizza, or maybe someone just sprayed pizza scent inside the house. You're making inferences based upon what you've seen. Previous experience, so you know from the past that Mom usually buys pizza on Mondays or Tuesdays, and so you're making that inference then that it must be pizza night. Okay, for someone who's different, they never eat pizza, they would probably draw a different conclusion. So inferences are based upon your previous experience and prior knowledge per person. There's no such thing necessarily as a wrong inference as long as it's drawn within observations. So if you walk in your house and you smell pizza and say, there must be a football game on TV tonight, that wouldn't be a proper inference because you're not drawing an inference based upon the observations that you made. And then you can change your inferences with new observations. So then you walk into the kitchen and it's empty, no pizza in sight. You're going to probably draw a different inference then. So here's an example of an observation. You get up in the morning and the grass outside is wet. So make an inference, just one inference, about what happened. Pause the video and give this a shot, then resume it. Remember, this is based upon your prior knowledge, your thoughts, and so your inference might be different than mine, might be different than someone else's. Okay, so here's my inference then. I go outside and the grass is wet. Well, my sprinklers go off on Tuesday nights and it's Wednesday morning, so therefore it was probably the sprinklers that got the grass wet. Now, then I might walk to my backyard and look at my sprinkler system and see that it's broken, and then I would have to draw a different inference because my observations changed, or a new observation changed what my original inference would be. Your guys' inference could have been something different, and that's okay. You could have said maybe there's dew outside because it was cold last night, or you could have said it rained last night. Any of those would be logical inferences. Different observations, different experiences are going to cause us to draw different conclusions. But if we think about this, though, the grass outside is wet. If we just draw an inference based upon that information, we're not doing a very good job. So something that's important in science and important in chemistry as well is we can't just draw a single or make a single observation and then draw an inference from that. If we stopped at one observation, really we wouldn't know as much about the atom today or chemistry as we do today based upon just that single observation. Instead, we'd have to make a variety of observations in order to make a clear inference on what exactly happened. And when we do that, that's where we get things like scientific theories and scientific laws and scientific hypothesis. They're based upon observations that we can make, that we've gathered, and we've analyzed to draw a very, very clear picture of what we think is happening or happened. So why is this important? Look at this picture right here. Do you recognize what this picture represents? You probably do. It represents an atom. So why is it that this is so recognizable as an atom, even though we've never seen an atom? Okay, this isn't a picture of an actual atom. This is something someone drew based upon what we perceive an atom must look like. We have microscopes that can zoom way in and they can see individual atoms, but really they just look like marbles dumped in a pile of mud. We can't really see any of their characteristics. We can just see that they're there. But how do we know what they look like? How do we know they have protons, neutrons, and electrons? How do we know that they decay, that they react, that they bond? We do because we make observations. Scientists make observations. They do it in a variety of different ways. From those observations, they pool them all together, and then they can make inferences based upon those observations, and then they can draw conclusions that we then call theories and laws. The atom is still technically a theory. We refer to it as the atomic theory because we've never seen an atom. Instead, we've made observations, we've drawn conclusions, and then we've come up with this model of what we think the atom looks like. So during the course of the year, we're going to be looking at a variety of ways that they made different discoveries, and we're going to see those observations and inferences that scientists do in their jobs. It's not always about a cookie-cutter lab where they do step 1 through 10 and then they get their answer at the end. They have to design their own experiments, make their own observations, and draw their own valid conclusions. And of course, I'll be asking you guys to do a lot of the same ideas.